All right, we're going to start with question 21 on this session. 21, 23, and we'll go through a bunch of them. We're going to try to prove identities again. This one probably a more difficult one of the set. So we're going to start with tan squared. Tan squared is going to be sine squared over cosine squared. And then we're going to subtract 1. Now, when I make this 1, what I'm going to do is I'm going to come up with common denominators, because this denominator right now is secant theta over 1. So all of it I'm going to leave over secant theta over 1, or minus 1, to start. And what I'm going to do is, to get this 1 to become secant minus 1, I'm going to multiply the top by that. And all of this is supposed to be secant theta. So what I'm going to do here is I'm going to distribute that minus sign through. And as I distribute the minus sign through, I'm going to change this secant to 1 over cosine. I'm going to also change this secant to 1 over cosine. So this is what we're going to have. It's going to look ugly. We got sine squared theta over cosine squared theta. That's just rewriting that. Minus, this secant is going to become 1 over cosine theta. And then that minus times that minus is a plus 1. And then all that is going to be over, I'm going to change this secant to 1 over cosine theta minus 1. And again, all this is supposed to be secant theta. Now I'm going to take the time to combine all of this in terms of one fraction. So there's my fraction bar in the numerator. The common denominator will be, I got a cosine squared, I got a cosine, I got a 1. So it's all going to be cosine squared theta. Well, this sine squared theta is going to stay the same. I multiplied this cosine by cosine, so I got to do the same thing to the numerator. So it's 1 times cosine or cosine. And then to get this 1, which is 1 over 1, to become cosine squared in the bottom, I got to multiply its top by cosine squared. And then that's going to be over. This, what I'm going to do is, again, combine fractions. Subtract this, combine it as one term. My common denominator would be cosine. That 1 stays, and this 1 changes to cosine theta over cosine theta. So there we are. And all this is supposed to be secant. Now in my next step, I'm going to try to do my state change flip and see what that looks like. But at the same time, I'm going to notice that I have a sine squared plus a cosine squared. And a sine squared plus a cosine squared is 1. And that takes care of that and that. And then it's going to leave me with cosine theta in the top divided by cosine squared theta in the bottom. That's my stay when I simplify. I'm going to change division to multiplication. I'm going to bring this guy up and I'm going to flip it. Cosine theta over 1 minus cosine theta. And all this again is supposed to be secant theta. And if you look, that will cancel with that because they're binomials in the numerator and denominator that are perfect to get rid of. This cosine will go into this cosine once. And I'm going to bring the result up here. And if you take a look at what we have left, we just have 1 in the top over just a cosine in the bottom, and that's supposed to equal secant of theta. So we have secant of theta is equal to secant of theta, and we are done. Nice difficult question that you just were able to get through. All right, we'll move on to page 488, number 23. And with this question again, what I'm going to try to do is, if you take a look at the denominator, here you got 1 plus sine theta. The denominator over here is a 1. So I'm going to put all of this over 1 plus sine theta. Okay, which means this sine theta is going to have to be multiplied by 1 plus sine theta to get that common denominator. The cosine squared stays as cosine squared because its denominator stayed the same, and that's supposed to equal 1. Obviously, we're going to freeze this side. I'm going to distribute the sine through. Sine times 1, sine theta, plus sine times sine squared theta, plus cosine squared theta. All that divided by 1 plus sine theta, and that's supposed to be 1. And you can see we got those to cancel, and that's going to leave me with sine theta plus 1 over 1 plus sine theta, and that's supposed to equal 1, and 1 is equal to 1. And we're done. Alright, moving on. That was 23. Let's see where I have the next question. Here we go. Moving to question 25. Alright, we got cosecant over sine minus cotangent. So I'm going to take my time and I'm going to try to change everything that I can. So my cosecant is going to be 1 over sine theta, and that's going to be divided by the sine of theta. Then we're going to minus cotangent is going to be cosine squared theta over sine squared theta, and that's supposed to equal 1. Obviously, again, we'll freeze that side. I'm going to do a state change flip over here. So it's 1 over sine theta, bring that up, times 1 over sine theta, minus cosine squared theta over sine squared theta, and that's supposed to be 1. And when we put this all together, you can notice that we have common denominators. The common denominator is going to be sine squared theta. That's what that is. So I have 1 minus cosine squared theta in the top is equal to 1. And you can see using Pythagorean's identity, I'm going to plug in sine squared theta plus cosine squared theta. That's my 1. Then minus cosine squared theta divided by sine squared theta is 1. And when you take a look at that, they'll cancel, and that'll leave me with sine squared theta over sine squared theta, and that's supposed to be 1. And sure enough, we bring this up over here, 1 is equal to 1, and we're done. Alright, now we're moving to page 488. We're going to go over the even questions now. This was the homework problems that I assigned after we finally finished that classwork piece. So moving over to here, I got a lot of room, so let me move this back over. Didn't know how much room I had. Alright, so we can see this. Okay, so now these problems should start back to be a little bit easier than the ones that we just finished over here. Alright, so changing everything to sines and cosines. Tangent is sine theta over cosine theta. We're going to multiply that by sine. We're going to multiply that by cosine. And we need to get sine squared. The two cosines will cancel because we're multiplying. We can do that. Sine times sine is sine squared theta is equal to sine squared theta. And really quickly, we're done. Alright, next question, dropping down to 6. Let's get this set up. There we go. I think we're good. Alright, so again, here, we're going to we'll freeze this side, and we'll work with this one. I'm going to distribute the secant through before I change anything. So I'm going to go secant theta times cosine theta minus secant theta times cotangent of theta, and that needs to be 1 minus cosecant theta. Now I'm going to change it. Oh, sorry, this is secant. Now I'm going to change this. Secant is 1 over cosine, and that's going to be times cosine minus secant again, 1 over cosine times cotangent is cosine over sine, and that's supposed to be 1 minus cosecant theta. The two cosines here will cancel, leaving me with a 1 minus, these two cosines will cancel, 1 over sine theta, that has to be 1 minus cosecant theta. And 1 minus 1 over sine. 1 over sine is cosecant. And done. Okay, page 488. Page 488. Again, I'm going to change here. I got my 1. Minus cosine, I'm going to leave. Secant becomes, 1 over cosine theta. And all this needs to be equal to sine squared of theta. State change flip, I get 1 minus, this will be cosine times cosine, which is cosine squared theta, and that needs to be sine squared theta. Once again, that Pythagorean theorem comes in. 1 is sine squared theta plus cosine squared theta, that's 1. And then minus my cosine squared theta needs to be sine squared theta. The two cosines are gone. We have sine squared theta is equal to sine squared theta. And again, we're done. Moving on, last 4 to this video. Right now we're jumping 488. I believe we're on number 10. Make sure we're inside our recording screen here. Here we go. Okay, again, you got a choice. You can change everything first if you want to, or you can distribute the sine through. I think it might be easier to distribute the sine through first. So I have sine of theta times cosecant of theta, sine of theta times sine of theta, and that needs to be cosine squared of theta. Obviously, we'll freeze this side. Changing things now, I have sine of theta times cosecant, which is 1 minus, or 1 over sine of theta, minus, then we have my sine squared of theta equals cosine squared theta. This becomes 1 minus sine squared theta is equal to cosine squared theta. Once again, the 1, there it is, Pythagorean's identity, sine squared theta plus cosine squared theta minus sine squared theta equals cosine squared theta. The two sines will cancel, and I'm left with cosine squared theta is equal to cosine squared theta, and we are done. Okay, let's take a look at question number 12. Question number 12, change things right away. Sine is going to be, our tangent is going to be sine of theta over cosine of theta. Obviously, we're going to freeze this side. Divided by secant is 1 over cosine of theta, and all this needs to be equal to sine. State change flip, sine of theta over cosine of theta times cosine of theta equals sine of theta. And they will cancel. Sine of theta is equal to sine of theta, and we are done. Next one. Moving down to question 14 on the even ones from page 488. Make sure that we're inside the recording screen, recording area. I think we're good. Okay, so once again, same thing. Cosecant over secant. Let's change that. Obviously, we're going to freeze this side. Cosecant, we should start to be getting used to. Said it 1,000 times already. 1 over sine, secant, 1 over cosine, and this needs to be cotangent. State change flip, 1 over sine theta times cosine theta over 1 equals cotangent theta. We multiply cosine theta over sine theta equals cotangent theta, and we have cotangent theta is equal to cotangent theta, and we're done. And finally, last one on this side. Ooh, looks to be difficult, but I think what we're going to try to do is we're going to try to combine everything. To get started here, we will freeze this side, and we're going to come up with a common denominator. Our common denominator should be sine theta cosine theta. Well, that's this denominator, so the 1 is going to stay, minus, I multiplied this denominator by cosine, so multiplying its numerator by cosine, I get my cosine squared theta, and then all this is supposed to equal tangent of theta. Now again, 1, I'm going to substitute in for that sine squared theta plus cosine squared theta, so let's take a look what that will look like. Sine squared theta plus cosine squared theta, that's the 1, and then minus cosine squared theta. All of that is over sine of theta, cosine of theta, and we need that to become tangent. You'll see here the two cosines will cancel, leaving me with sine squared theta over sine theta cosine theta. That needs to be tangent of theta. How am I doing on my room? Good. Well, I can cancel that sine with one of those, and now I have sine theta over cosine theta, and that's supposed to be tangent theta, and we should know that sine over cosine is tangent, and we get tangent is equal to tangent, and we're done.